Okay, so when we want to relate a measurable quantity like mass that we can make in the laboratory to our theoretical understanding of chemical processes, which is in terms of atoms and molecules and ions and so on and so forth, we must use this concept of the mole as a conversion between that. And typically we will really be concentrating on the relationship between mass in grams and moles for the time being. And so we can convert between grams and moles using the calculated molar mass, which we obtain, of course, by adding up the component atomic masses. So if we want to go from mass in grams to moles, we are going to use our molar mass, and we can go back and forth using the molar mass as a conversion factor. If we want to go from moles to atoms or molecules or ions, we are going to use Avogadro's number because we define Avogadro's number as 6 times 10 to the 23rd units per mole. Okay, and so I wanted to do a couple of quick examples here. So for example, if we have 25 grams of iron 3 hydroxide, that is ferric hydroxide, how many moles of ferric hydroxide do we have? Okay, and so our first step is going to be to figure out what is our molar mass of ferric hydroxide, iron 3 hydroxide. So to do that, we need to know the formula of this substance, and iron 3 means that iron has a +3 charge, and we know hydroxide has a -1 charge. So our formula is FeOH3, and when we add up the 1 mole of iron and 3 moles of oxygen and 3 moles of hydrogen, we see that it has a molar mass of 106.9 grams per mole. Okay, so 1 mole of ferric hydroxide weighs 106.9 grams. So now we're going to use this as a conversion factor between grams and moles. Okay, so we begin with 25 grams of FeOH3, and we're going to multiply by a conversion factor derived from that molar mass. So this conversion factor is that 1 mole is equal to 106.9 grams. Since we want moles, we are going to write 1 mole of FeOH3 per 106.9 grams of FeOH3. We see that our units here, grams, will cancel, and we'll be left with the units that we want. And so now we just plug into our calculator 25 divided by 106.9, which will give us 0.23 moles of FeOH3. That looks terrible. Looks too much like a C. FeOH3. Okay. Now, if we wanted to know how many iron atoms are present in that 25 grams, we're going to use Avogadro's number as a conversion between moles and numbers of molecules up here. Okay, so we already know how many moles in this case because it's exactly the same as the previous question. So we're going to take 0.23 moles of FeOH3. That's where we begin. And we want to know how many iron atoms, right? So we have to figure out how many iron atoms are in a molecule or a formula unit of ferric hydroxide, which in this case is 1. So we're going to say that we have 1 mole of iron atoms for every 1 mole of iron 3 hydroxide. Okay, so now those units cancel. We've gone from moles of ferric hydroxide to moles of iron atoms. And now we're going to use Avogadro's number. 1 mole is equal to 6 times 10 to the 23rd units. So in this case, we will multiply 6.022 times 10 to the 23rd atoms per 1 mole of atoms. Okay, and so in our calculators, all we have to do is take that number, 0.23 moles of ferric hydroxide, times Avogadro's number, telling us we have 1.4 times 10 to the 23rd iron atoms in 25 grams of iron 3 hydroxide. Now, one more quick example here before we finish. Remember from our molar mass video, or if you don't, we will explain it again, that many ionic compounds contain water as part of their formula unit. And so we have things like cupric sulfate pentahydrate, which contains 5 moles of water for each mole of cupric sulfate. Okay. And so if we wanted to know how many grams of this substance do we need to weigh out to get 1.75 moles, we're going to sort of do the opposite of what we've done up here. So rather than going from grams to moles, we are going to be going from moles to grams. And once again, we're going to use that molar mass as a conversion factor. So in the case of cupric sulfate pentahydrate, okay, we can calculate the molar mass. There are 5 moles of water and 1 mole of copper and 1 mole of sulfur and 4 moles of oxygen for every 1 mole of this substance. And we will find that it has a molar mass of 249.7 grams per mole. So now we're going to begin with our 1.75 moles of CuSO4 5H2O. And we're going to now use our molar mass. This time we're going to multiply by that molar mass, grams of CuSO4 per 1 mole of CuSO4. Seeing that now our moles are canceling, and we're left with what we want, grams. And so we're going to take 1.75 times 249.7, telling us we need to weigh out 437 grams.